Today, this will talk about analysis of the pulses used in EDM. This is the process. So then today we talk about overview of EDM parameters. What kind of parameters you can control? There are a lot of things. Then we talk about the EDM variance. EDM, there are a lot of EDM categories, and we are going to talk about them one by one. And you should know that one in our final exam. And I will basically ask you to tell me what are these EDM variants. So this is an overview of EDM parameters. So EDM parameters can be categorized into operating parameters, all these process control parameters that you can control, and performance parameters or machining characteristics. So the operating parameters are those that have significant impact on the machining performance. So changing those operating parameters based on performance requirements and/or applications can change the machining condition. So the operating parameters are, right? So you should be able to tell me this. Can be electrical, on which the discharge unit and pulse generator maintain. So these parameters are polarity, open circuit voltage, and gap voltage. If you can make some mark here, and you can just make some annotation. The peak current, pulse duration, pulse interval, and pulse frequency, duty factor, etc. So these are parameters. So non-electrical parameters are mainly the material properties of the workpiece. Electrode is very, very important. So electrode will be regarded as the tool, right? It is a tool in the machining of this workpiece, and dielectric. So another important set of operating parameters is the motion and the gap control parameters, so which are primarily responsible for machining stability and accuracy. So the motion parameters include electrode and workpiece rotation and vibration. The electrode is spinning. Also the vibration, tool electrode, the geometry. What is the geometry of the electrode? The design and shape, and wear tension and vibration, etc. Also, there are several feed and EDM feed are the two important gap control parameters. In addition, the flushing taps and the flushing pressure also have significant impact on EDM process performance. So here is operating parameters. The performance parameters or the machining characteristics of outputs, and by which the final product is evaluated. So this is very, very similar to what we have learned in the machining. In machining, we have some independent variables and we have some dependent variables. Independent variables include those that we can control. The dependent variables include some results, the outcome of the machine. So these are the same thing here. These are performance parameters. So the most widely used performance parameters are the MRR. And what is MRR, everyone? Can somebody tell me?
Material removal rate.
Yes, great. Material removal rate, electrode or tool wear ratio. So there's as I said, electrode in this is EDM context is regarded as a tool. So electrode will be worn also. So if there's a electrode tool wear ratio and surface roughness, in addition, the spark gap width or this overcut is used for the measurement of dimensional accuracy of the part. So you should know what the operating parameters are and what the performance parameters are. The performance parameters are greatly dependent on the operating parameters, definitely. So this is operating parameters, they are independent one that you can control performance parameters and other results of operating parameters. The MRR greatly depends on the process parameter. A high level of discharging voltage, peak current, the pulse duration, and duty cycle, along with lower values of pulse interval, can result in the higher MRR. So, however, the pulse with a condition with shorter discharge duration and lower peak current bring about both lower tool electrode wear ratio and better surface roughness. It is seen that the tool wear characteristics are associated with material properties, especially the boiling point. So there are a lot of other things. The volumetric wear of the ratio of the electrode becomes small for the electrode material with high boiling point, so the high melting point, and this is high thermal conductivity, which is independent of the workpiece material. So the increase in gap, voltage, peak current, and pulse duration, and usually results in increased electrode wear ratio. The surface topography and roughness are largely determined by the inroad crater size and crater uniformity relating to the discharge pulse energy. So a low open circuit voltage, shorter pulse duration, with higher frequency and enough higher the pulse interval produces small craters and hence less surface roughness. So you can see, so this is the Dr. Jackson wrote this is the paragraph based on the literature he has read. Okay? The surface roughness slightly increases with the increase of peak current value up to a certain level, and then vigorously increases with any increase in peak current. So when compared against different electrical fluid pressure, and surface roughness shows slightly decreasing trend with increasing pressure. So this is also from the conclusion of some papers here. Again, depending on electrical and thermal properties of the workpiece and electrode material, the surface roughness varies. So this is from the reference 28. It has been found that the spark gap has a proportional relationship with the gap voltage. However, the spark gap and the surface roughness are also influenced by the pulse on time. So the peak current and applied energy influence the spark gap. Therefore, the main parameters affecting spark gap were identified as open circuit voltage and peak current and pulse on time. So underscore this sentence, I'm going to ask you guys, okay? What are the three main parameters that affect the spark gap? Open circuit voltage, peak current, along with the pulse on time. Any questions regarding this is the parameters, operating parameters, performance parameters. Operating parameters are independent variables that you have control. You can control. Performance parameters are the outcome parameters from your operating parameters. So they are dependent variables. And then we talk about EDM variance. There are several different categories of EDM. We have, this is the die-seeking EDM, so this is very version. We have wear EDM, so as the name suggests, user wear. This is the electrode is continuously circulating metallic wear. The third one is, this is the EDM milling. And the fourth one is EDM drilling. And so we have rotary disc electrode electrical discharge machining. So dry or near dry EDM milling. So we have so many subcategories, planetary EDM. And so in the final exam, I'm going to ask you guys, okay? Reverse EDM. And we're going to talk about this one by one. So as I said, you need to put a star mark there and tell you that, so this will appear in the final exam. So first one is we call die-seeking EDM. So it's also called a seeker and seeker EDM, also cavity types EDM or volume EDM is one of the two most common types of EDM. So in die-seeking EDM, the electrode is shaped and produces its negative form into the workpiece. So the typical part geometry is a complex 3D shape, often with small or odd-shaped angles, the typical part geometry. The wear has to be very low in order to keep the electrode's original shape unmodified during the whole machining processes. The electrode is generally is copper or graphite. And so I will ask you, what are these electrode material? And for this is a die-seeking medium. So copper or graphite, and the dielectric fluid is oil. So the asymmetry in the MRR is thus crucial for die-seeking. The servo controller monitors the gap conditions between the voltage, gap conditions, voltage and current, and the synchronously controls the different axes and to machine the mirror image of the tool. So this picture shows the schematic representation of the die-seeking, the 6.17. 6.17. This one. So here, electrode movement along is the z-axis. And you can see here is we call it asymmetry. The asymmetry in MRR is thus crucial for die-seeking EDM. So whenever you see this asymmetry, and you can see that this is a die-seeking EDM. So this is one of the characteristics of die-seeking EDM. Okay, everyone? So die-seeking EDM is mainly used to produce injection molds and complex 3D structures in industry. And high wear resistance composites based on refractory materials such as tungsten, copper, or cemented carbide are preferred in die-seeking this EDM. Conventional flushing strategies cannot be used in micro die-seeking EDM, and since flushing through the electrodes is not possible because of their small dimensions. So together with the extremely small gap widths, the poor flushing conditions and put greater demands on the speed control in the die-seeking micro EDM. So this is figure 16.8 presents application examples of die-seeking for machining dies, for mobile phone modes and cavities for micro mixing device. So here, see? So these are dies for mobile phone, and they just these dies use the EDM, so the die-seeking EDM. So here is the die-seeking electrode for machining micro mixing device made of fine-grained graphite. This is die-seeking is very important EDM, the EDM machine. The second one is wear the EDM. The wear EDM, as the name suggests, the wear is used. The electrode is continuously circulating the metallic wear. The typical diameter is 0.1, and usually they are steel, brass, or the copper. They are used electrode, which cross the workpiece along a programmed path. You need a program. The basic mechanisms of wear EDM is same as EDM. So die-seeking, I'm talking about die-seeking EDM here. And the material is removed as a result of a series of electrical sparks between the workpiece and wear electrode. Because since controlling the horizontal position of the upper wear guide relative to the lower guide can change the wear orientation. All types of root surface can be cut by wear EDM. We can just cut it. So a discharge currents with a high peak value over a short duration are used. The current is supplied through both the upper and lower feeding brushes and to obtain a quick rise in the discharge current by reducing the inductance and to avoid wear breakage and due to heating. As I'm going to show a picture. So this one is EDM, wear EDM. So here, the tension is applied to the wear to reduce vibration and deflection, which deteriorates the cutting accuracy. Mostly, the deionized water is used as the electric rather than electrical oil, and the most commonly used wears are brass, tungsten, and coated wear. The wear is capable of achieving very small cutting angles. The wear is less problem than in die sticking because eroded portion of the wear are continuously replaced by new one due to the wear circulation. This is important for this wear EDM. So this picture shows the wear EDM. So here is a wear, okay? This electrode, this wear, and this is a wear guide. Here is the electrical nozzle, and the electrical fluid coming from this nozzle to this machine area. So this is the wear. So here is a zoom in here. Zoom in. We have, this is the wear, right? So here is a spark gap, and here is a slot. This is a slot. And slot is also called curve. This is slot. So because separating workpiece, and separating workpiece, you can just cut this slot this way to separate the workpiece. So this technique enables the fabrication of highly complex recess and complex components, and is used in prototyping, in tool and mold manufacturing, and in series production. Wear EDM is the most commonly used process for direct production of mechanical devices and for micro stamping tools. Axisymmetric products can be machined by micro wear EDM with a rotating workpiece system. So here it shows the features machined by EDM and micro EDM. So here is the micro EDM. That's the complex modes for injection molding. And the piers, this one, the piers machined by wear EDM, the piers. Here is a Chinese pagoda. So this is also machined by the wear EDM. It is very beautiful. So the image of this complex mode and the piers machined by wear EDM, I show this also. I'll just talk about it. The capability of wear EDM is fully exploited in the machining of complex Chinese pagoda. So here, you can see different shape here. Any question regarding this wear EDM? So this is our second category of EDM. Right? As I said, and so this will appear in our final exam. Then we talk about EDM milling. So we know milling. We know this is milling. We have this is base milling. We have slab milling. We have up milling and the down milling. So this is end milling. So EDM can be also used as a milling. EDM milling is an improvement on the EDM. Previously EDM is used to generate some features. Now we can use the EDM to mill something. So similar to numerical controlled milling, it uses a universal tool electrode of simple shape, spherical or cylindrical, that moves along a complex path to machine hard material, to this machine hard material, controlled. In this process, is controlled using usually tubular or cylindrical microelectrodes are employed and to produce the desired compact shape by scanning. So a cylindrical electrode rotates. Okay, the electrode is rotating across its axis with the scanning movement in X and Y directions. The contour of the particular layer is specified in the part program of CNC. You need to know that it is a program, CNC program. So, however, electrode compensation is an important factor to consider as electrode length is reduced of the scanning area layer. So you should know that. So the electrode is being worn away also. So as what happened in the machining. And this figure shows the schematic presentation of medium EDM. I'm going to show you this medium EDM. So electrode rotation around Z, this guy is rotating, okay? This is the scanning movement along X or Y axis. So here is just like the medium we are familiar with when we talk about the machining. So in addition, this EDM medium enhances the dielectric flushing and due to high-speed electrode rotation. So this is, it itself is rotating with high speed. So however, the main limitation of EDM medium is that complex shapes with a sharp angle cannot be machined because of the rotating the two electrodes. So you should know that this is the limitation. Limitation means that the disadvantage. So aluminium is now replacing the die-seeking EDM in many applications of producing dies and 3D cavities, as die-seeking EDM requires fabrication of complex 3D electrode and using other machining processes. Okay? And I might ask you guys, why is EDM medium is replacing the die-seeking? So you need to know that. So die-seeking EDM itself requires fabrication of complex 3D electrode and using other machining processes. And both blind 3D cavities and through starters can be machined using the EDM process. This is very, very good. Blind cavities and through starters. You know blind cavities, right? Okay? You know blind holes. You know blind holes, right? Blind holes, that means, what's blind holes? Blind holes, the hole is not through. It's not through hole. We have through hole, we have blind holes. The blind starters, the through starters, that means this is suppose this is the thickness. I have some structures. All these structures, they are through, they are deeper than the thickness of the material. That is through structure. So the application of EDM medium is more pronounced at micro scale, using a micro scale as fabrication of microelectrodes with 3D features for die-seeking micro EDM is a real challenge. So this figure shows example of 3D structures fabricated by EDM and micro EDM process. This one, okay? So very, very beautiful. Micro pyramid means using the 3D EDM medium. This one. B is 1/4 in a square cavity. Is a square cavity and build the ball. And the professor didn't want to show us how to build, how to have this is a cavity, and how to build, how to the machine is this 1/4. So this one is a complex 3D cavity by the CLU method, combination of the linear compensation method and the uniform wear method. So here is how the applications of EDM medium. Any questions with the EDM medium? This is our third category of EDM. The question, the last one is EDM drilling, not the last one, is the next one. EDM drilling. Let the drill the blind hole or through hole. So the EDM drilling, the electrodes are used to drill holes in the workpiece. The both tubular and solid electrodes are used for the drilling purpose. For tubular electrodes, the gas flushing inside the tube is used, whereas for the solid electrodes, a dielectric is fed to the machine zone and by either suction or injection through the pre-drilled holes. So, for tubular electrodes, they have a jet and to flush. The problem with deep small hole drilling by EDM is that forming and clamping is difficult. So therefore, the microelectrodes are used to fabricate on machine with high accuracy using different micro-efficiency deep grinding process. This also solves the clamping problem because the electrode is clamped before the forming process and never reclamped until the hole is machined. So this picture shows the consecutive process of on-machine electrode fabrication by wire electrode discharge grading and block EDG and EDM drilling with fabricated electrode. So here, so these are three, okay? So this is the first one, fabrication of electrode using wire electrode discharge grading. So here is a blank workpiece. This workpiece, raw workpiece. This is the tool electrode. And so this is electrode discharge bed. So this is a workpiece feed direction. So here, I want to have this one. The second one is fabrication of electrode using block EDG process. So this is a sacrificial electrode. This is a tool electrode. And these two guys, when these two guys come together, and they will have these sparks. And this is some material will be removed. So the last one is the EDM drilling using the fabricated electrode. So this is the fabricated electrode, and we want to use the electrode. You can see this hole is very, very deep, but the diameter is very, very small. And what we call this high aspect ratio the features, right? So all kinds of micro holes, for example, any irregular, taper, curved, as well as inclined, the holes can be produced using the EDM drilling process. Machining of high aspect ratio holes for fuel injection nozzle and cooling channels in turbine blades made of hard materials are few typical application of EDM drilling. So this picture shows the fabrication of high aspect ratio micro holes with different diameters and application of micro EDM drilling in automobile and aerospace industries. So here is a 6.5 micrometer hose. Very, very small. Here is a fuel injection for diesel engine in automobile. So diesel hose. So this one magnified image of the micro hole shown in panel B. Right? So this is magnified. This is using the EDM drilling. And my bottom line is that you know what is EDM drilling and what are these engineering applications of EDM drilling and how to build this EDM drilling electrode. Questions for EDM drilling? So question, we talk about another category, rotary disc electrode EDM. So this is one of the variants of the process of EDM process, and based on removing material by means of series of recurring electrical discharge between a rotary tool called disc. The thickness ranging from micron level to 1 millimeter, and the work material in the presence of the electric fluid. For example, kerosene and distilled water. The disc is commonly made of conductive hard materials such as tool, steel, or carbide, and the thickness ranging from several microns to few millimeters. I'm sorry. The commonly used dielectric fluids for this process are kerosene and deionized water. And the cutting speed of this process is reported to be twice of that of the conventional abrasive soil method. So that means so this is material removal rate will be double. Is double. The process is used for cutting of billets and bars with a smaller curve and burr-free surface. So this picture, right? So this picture we see card. This is this picture shows the principle of RDEDM process. The fabricated microstructure using this process for different applications are presented in figure 6.16. So this one shows this is a rotary. Let's see, this is a rotary disc. It works as an electrode. So this electrode discharge. Here, this guy is rotating and also can be fed around this direction. So this is straight the groove, and this is debris, and so this is a workpiece. So here is the example of RDEDM. So you can see the slots there. Here, I'll go here for this one. Different lines. It's very beautiful, right? So, and here also C is a series pattern micro disc fabricated by multiple within disc electrode. This multiple disc, just using this RDEDM. So this is our the fourth one. The next one, let's say die seeking, where EDM, EDM medium, and EDM drilling. And so this is the RDEDM. And then this fifth one, and we have dry or near dry EDM medium. So the dry or near dry EDM can be die seeking type or milling type. So however, the application of dry EDM is found to be more effective as milling EDM, and due to the improved crushing of debris by electrode motion. So the dry EDM uses oxygen or air as the electric medium. So this is very awesome. On the other hand, the near dry EDM uses liquid gas mixture or mist as the dielectric. So the mist dielectric can be mixture of gas medium, for example, air or nitrogen, and liquid or water / the kerosene. And in this process, usually a thin walled tubular electrode, that is tubular, is used through which the high pressure gas or air is supplied to the machine result, the through tube. As can be seen from this figure, figure 16, the role of the gas is to act as dielectric and removing the debris from the gap and also cooling the internal electrode gap. Although the dry and near dry micro EDM has been found to be a variant of die seeking or micro EDM with gas medium of dielectric, and there are significant differences in plasma polarization, gap control, along with the material removal mechanism. So this is the dry or near dry EDM machine. See? These are the features, and they can do it. electrode rotation is a tube, and this is a tube. This is a medium can be fed, either gas or gas liquid mixture. So far, the dry EDM has been used for replacing conventional die stacking and EDM milling as the removal of debris becomes more difficult in die stacking EDM. Without the help of the electrical flushing, the dry EDM is found to be used more extensively than die stacking. The dry EDM, that means no the electrical fluid. Is capable of machining spherical surface, fine curved slots, and micro and mirror-like machine surface, as reported in the video. So figure 18 shows example of machining spherical surface using dry EDM. So this one. It's very, very beautiful. Do you guys agree? Very, very beautiful. Here is a skill. So these are our six. This is the sixth category of EDM. Any questions regarding this dry EDM? Dry EDM means that we do not use the electric fluid. Near dry means that we can use the gas. It's just a little bit. Do not use it too much. We don't need to submerge the workpiece in the electrical fluid. So next one is a planetary EDM, as the name suggests, planetary. Significant enlargement of the field of application of die stacking EDM or EDM drilling is a so-called planetary EDM. In the planetary or orbital EDM, a spatial translation movement of the tool electrode overlaps the conventional rectilinear stacking movement. The planetary or orbital EDM using the movement of electrodes was found to be very useful, particularly in drilling of microholes, as brushing is more difficult for thin this electrode. A common problem until these die stacking EDM or EDM drilling is the debris accumulation, which becomes worse during machining high aspect ratio microstructures. Adding a relative motion between the electrode and workpiece, other than the electrode feeding motion, produces a wide clearance between them for fluid circulation and then reduces debris concentration, resulting in high MRR, low electrode wear ratio, along with high machining accuracy. So this is 19 shows the planetary or orbital EDM, indicating the motion and path of the electrode. So this is the planetary EDM. So this is electrode orbital radius. This is orbital radius. So this is the thickness. So here is the hole. The cylindrical slicing can do the cylindrical slice, right? And Z is a sphere. So here is application example of planetary EDM. This is the hose. It's very, very good. And then we talk about the last one, the reverse EDM. The reverse EDM is also a variant of EDM in which it is used as a microscale nowadays. The reverse micro EDM is being accomplished by reversing the polarity, and so that the material enrolls from the larger diameter rod, and the polarity of the electrode and the superficial workpiece is interchanged during reverse micro EDM, so that the electrode can be extruded among the arrays of micro holes. In this process, the electrode is considered as a workpiece and is fed down the hole of the metal plate and to be machined by electrical discharge. At this time, electrode is considered as a workpiece. which occurs within machine gap. However, the regions that corresponds to the hole are not machined. So finally, microelectrodes are machined as many as the holes. So the principle of reverse micro-EDM is presented in this picture. We'll talk about this one. The fabricated array of micro electrodes with similar or different diameters using reverse EDM. I'll show you this figure 21 and 22. Here is a 21. Fabricating micro electrodes using reverse micro EDM. So it just changes the priority. So this electrode and this workpiece. So here is this application of reverse EDM. The card, see, very beautiful. Huh? So we totally have 8. We totally have 8 1. We totally have 8. This is different the categories of EDM, and you should know that. Okay? And then we talk about this is the examples of research advanced in EDM, and this we just we have 5 minutes and do as much as we can. So in EDM is very it's proved that an EDM is very capable of machining difficult to cut materials and irrespective of their hardness, no matter how hard it is, as long as it is conductive. It suffers from several shortcomings, right? So there are limitations here, such as low machining speed, a heat effective zone because of high temperature, higher tool wear, poor surface finish, etc. So therefore, in recent years, the research focus has been moved towards the development of hybrid machining process, combining EDM with conventional machining processes. The method of two constituent processes may be applied sequentially and simultaneously to constitute compound and hybrid machining processes, respectively. The compound machining is defined as a combination of two different machining processes in a single setup applied one after another. On the other one, the hybrid machining process is defined as integrated application or combination of different physical active principles in a single process. In the following sections, there are some developments in the area of EDM-based compound and hybrid machining process, along with application materials will be presented. Any questions so far? I'm going to stop now. So today we have talked about the 8. We talk about 8 different categories of EDM. So do you have